Dividing refers to separating into equal groups. If we want to separate 24 into 4 equal groups, then we're implying that we are dividing 24 by 4. So it means divide 24 by 4. And we can request that division in a couple of ways. We can say 24 divided by 4 using this notation for division. Or we can actually use a fraction bar. This says 24 divided by 4. You see, they mean the same thing. Now, in this process, we usually use a little mathematical symbol, a little division symbol that looks like this. And we say that we're dividing 4 into 24. The 4 is called the divisor, 24 is called the dividend, and the answer in the process is called the quotient. Now, in this division business, we're separating into equal groups now, and how many equal groups, you see, with 4 in each group, will make 24, and it turns out to be 6. And we can verify that this is correct, that there are 6 equal groups, you see, with 4 in each group, like this. We can say, well, let's see, 6, if we have 6 groups with 4 in each group, that's a total of how many items? Well, it's 6 times 4 items, you see, or 24 items. 6 times 4, 24. So this is a way to verify that we are performing the division correctly. So, divisor, dividend, quotient. Now, the check on it, notice that the check, I performed the check here of 6 times 4 is 24 in order to verify that this is correct, that 6 is indeed the quotient here. And that check, notice, is quotient times divisor is equal to the dividend. So quotient times divisor is dividend. This is the way to check division problems. Let's talk about some special division problems. If we were talking about 5 into 5, we're dividing 5 by 5, or for that matter, any number into itself. We're trying to divide 5 into 5 equal parts. How many items would be in each one of those equal parts? Well, it turns out that each one of those equal parts would have to contain 1 item, because 1 times 5 is 5. And in a similar way, if we're dividing 12 by 12, you see we're trying to separate 12 into 12 equal parts, then each of those parts would contain 1 item, because 1 times 12 is 12. 1 as a divisor, 1 into 7, kind of means, you see, if we're thinking about this equal parts idea, how many items would be in the parts if we were going to separate 7 into 1 part? Well, if 7 is divided into only 1 part, then all 7 of these items would have to be in that part. So it's 7, because 7 times 1 is 7. In other words, when we divide 1 into any number, it turns out to be itself, you see. And that number times 1 is the number we started with. All right. Is that the dividend? 1 into 25. You see, we're separating 25 into 1 part, and that part has 25 items in it, because 25 times 1 is 25. 0 is kind of a special dividend. If we divide a number into 0, now think about this division symbol as being a request for a number, the quotient, which can be multiplied times the divisor to give this 0 dividend. You see, what times 4 is 4? That's a kind of a good way to look at it. What times 4 is 0? You see, what times 4 is 0? Well, 0 times 4 is 0. You see, and any time 0 is the dividend, it turns out that the quotient is going to be 0. 15 into 0, that is, what times 15 is 0? Well, 0 times 15 is 0. Now, let's let 0 play another role. What if 0 is the divisor? That is, what if we have 0 into some number? What times 0 is 5, you see, is the request here. Is there any number that we can choose that we can multiply times 0 to get 5? Go like this. No! Therefore, this is an impossibility. This is not a defined operation. We can't possibly divide by 0. Now, this division by 0 can appear in a couple of other ways. You know, it can be 5 divided by 0. That's impossible. 5 divided by 0 like this? Impossible. Let's talk about a somewhat more imposing problem. We're dividing 4 into this big number. Now we can think of the idea of separating the number into 4 equal groups, and how many items are in each of those equal groups. It's kind of hard to tell directly, isn't it? But what we can do is go through a process where we say, well, gee, these digits have value, and we can decide to make the separation, go through a little process for this separation into equal groups like this. We can say, well, let's see. Let's take the number of thousands and see if we can separate this 3 thousands into 4 equal groups. Well, no, we can't. We don't have enough to have even 1 in each of those 4 groups. So let's make this 31. That's 31. We have 3,100, so that's 3,100. So we'll take the hundreds and we'll separate the hundreds into groups. All right, now we want 4 groups, and how many does each group contain? That's what we want to put up here for those hundreds. And we can think about what times 4 is 31, you see, as verification here. Now we might think, well, let's see, would it be 5 times 4 to be 31? No. See, there's no actual number that we can multiply times 4 to get exactly 31. But we want equal groups here, so we want something times 4 to be a number a little bit smaller than 31. You see, because we want to know how many can fit into each of those groups. Well, let's see. 5 times 4 would be 20, and if I had 20 here, I would have a lot of leftover items, wouldn't I? How about 6 or maybe 7? 7. 7 times 4 is 28. So I can have 7 hundreds. Now notice that the hundreds are lining up here. I have ones, tens, hundreds. I'm putting 7 in the hundreds position up here, and I'm talking about hundreds for the 31. That kind of all makes sense, doesn't it? So it's going to be 700 and something for the equal groups for this big number. But I'm just dealing with this part. Now I have 7 in each group, have 4 groups, 7 times 4, 28, but I have some leftovers now. And to figure out how many hundreds remain, you see, to be dealt with, I can draw a line here and subtract. Now this is the way you learned this in the past. And I know that you've had it before, and we're talking about it in just a somewhat different way here, just to understand and explore the idea just a little bit more than we have maybe in the past. But we're taking 28 from 31. We can see that that's 3, I'm sure. If we want to subtract using the ideas that we talked about before in subtraction, it would be, let's see, 1 minus 8. Oh, it won't go. We need to go over here and borrow from the 3. It becomes a 2. The one that we borrow makes this 11. So we have 11 minus 8, 3. And then 2 minus 2, 0. Okay, so we have 3 hundreds left over, and we can't possibly have 4 groups using the 3, you see. We don't have enough. So we'll bring down the next digit. And now we have 3 hundreds here and 9 tens, so we have 39 tens. Now we can separate this 39 tens into 4 equal groups, or 4 groups. I won't say equal groups because there's no number that we can multiply exactly times 4 to get 39. We can come pretty close though. 9 times 4 is 36. And again, when we subtract, we get 3. We subtracted up here and got 3. We subtract here, 9 minus 6 is 3. We have 3 left over. That's 3 tens that are left over. And we'll bring in some more items. There's 2 ones, you see, or 2 units. So we have 32. 3 tens, 2 ones, 32. 4 into 32, oh, that's 8, because 8 times 4 is 32. And now we have divided 3,192 into 4 groups, and each of those groups has 798 items. And we can verify that. We can go through the check by multiplying 798 times 4. Let's do that over here. The check is 798 times 4. Well, let's see. 4 times 8 would be 32. I'm carrying 3. 4 times 9... let's see, is 36, and 3 is 39. I'm carrying 3. 4 times 7 is 28, and 3 is 31. 3,192, and that's my dividend from up here, so this is the correct answer. Sometimes the division process doesn't go evenly. That is, we can't actually separate into completely equal groups. And we saw the situation kind of as an intermediate step over here when we were trying to divide the hundreds into equal groups, and it didn't go evenly. We had some items remaining. We had a remainder. Well, that's possible in the overall division problem. Here, for example, we're trying to divide 3 into 7, or we're trying to separate 7 into 3 equal groups. Well, how many are in each group? And the dilemma can be illustrated like this. Here are 7 items, and if I want 3 equal groups, or 3 groups that have equal numbers of parts, then I might think, well, maybe 2. You see, I have 2 parts here, I have 2 here, and I have 2 here. But I have 1 remaining. You see, I have 1 left over. Now, that's going to be the case up here too, and let's see how it works out using the digits involved. We say that 3 goes into 7 2 times. 2 times 3 is 6. So we have 2 items in each of those 3 parts, or 3 groups. And we have, therefore, by this 6 items, but we have 7 up here, so we want to designate the remaining item. What remains after we make this separation into those 2 groups? Well, let's see, 7 minus 6 is 1, so 1 is called the remainder in the process, and we designate it like this. Now, we may have another way to designate the remainder later, but 3 goes into 7 2 times with 1 as our remainder. That's the way we'll look at it for the time being. Now, when remainders occur in division problems like this, we check the division problem a little bit differently. Now, remember, before it was quotient times divisor would give the dividend, but the quotient times the divisor here doesn't give the dividend. We have to simply add the remainder in order to arrive at the dividend. So it's quotient. Now, I'll write the numbers out to the side. Let's see, we have a quotient. The quotient is 2 times the divisor of 3. That gave 6. And then add the remainder of 1 to get 7, which is our dividend. So we have performed the division correctly. We're going to go through a number of other examples involving long division. And the examples are chosen because they represent some rather unusual circumstances involved with this process. Now, I know you've seen long division before, and if you feel comfortable to do so, take the problem down. When you first see it on the video, take down the problem and stop the video program and try the problem on your own, and then roll the tape to verify your answer. Well, let's get started. We're dividing 5 here into 3,542, and you know we begin the process just by saying 5 goes into 3. Oh, 5 doesn't go into 3, you see. And then 5 into 35. Oh, that's okay. 5 into 35 goes 7 times. And then we say 7 times 5 is 35. We draw the line and subtract. So we're subtracting 35 from 35, we get 0. Now, I can either write this 0 or not write this 0. In the long run, I'd like to not write it. I'd like for you not to feel like you have to write a 0 like this. I'm writing it here for emphasis. All right, the next part of the problem is to bring down the next digit and continue the division process. So I'll bring down the 4, and then think about 5 into 4. Now, the 0 is a little bothersome to me here. I'll take it out. All right, here we go. 5 goes into 4. Oh, 5 won't go into 4. We need more value here. We need a digit larger than 4 for 5 to go into this. So we'll need to bring down the next digit. But what are we going to do up here? You see, that's the dilemma. And there are actually 2 ways to think about this. One way is like this. We might say, well, 5 goes into 4 no times. And 0 times 5 is 0. And now subtracting, we get 4. You see, and then we bring down the next digit for 42 and continue the process. The other way to handle it is like this. We would say, let's say we're at this position. We just say 5 into 4 won't go. We need a 0 here as a placeholder, and we'll bring down the next digit. That's probably the way you'll end up doing it as we become more and more familiar with it. But it's okay to say 0 times 5 is 0 and do the subtraction and all of that kind of thing. All right, so we're dividing now 5 into 42. 5 into 42 goes 8. 8 times 5 is 40. And when we subtract, We have 2 minus 0 is 2. 4 minus 4 is 0. So our remainder is 2. So our answer, 708, with a remainder of 2. And we can verify the result by multiplying 708 times 5 and adding 2. And we should get 3,542. And we do in this case. And let me show it to you, that whole process. To check it, here's what we do. We multiply 708 times 5. You see the quotient times the divisor, and then add the remainder, and we should get 3,542. And we do in this case. Okay, next problem. Let's see. 3 into 5,162. Well, let's see. We just begin as we did before. 3 into 5, oh, that's all right. That's 1. 1 times 3 is 3. We subtract. 5 minus 3 is 2. By the way, it's okay not to write this little minus sign, the subtraction symbol here. I'm putting it here for emphasis, and you'll see it in your textbook as well. But as you become more and more familiar with the process, then you're not going to end up writing this minus sign in every case. But so let's just regard it as an optional item at this point. 5 minus 3 is 2. Now we bring down the next digit. And we say 3 into 21, oh, that goes 7. 7 times 3, 21. And it goes evenly. That is, these numbers are the same, so when we subtract, we get 0. And again, we don't need to write the 0. It's okay not to write the 0. We just bring down the next digit, and we continue the process. So we have 3 into 6 goes 2. 2 times 3 is 6. And again, gee, that went evenly. So 6 minus 6 is 0. Again, we don't have to write the 0. We just bring down the next digit. It happens to be a 2. Now, 3 into 2, wait a second. 3 into 2 won't go. What are we going to do now? See, this is the reason that I chose this problem, is because of the dilemma that we're faced here. Well, technically, the correct thing to do is to say, well, 3 into 2 goes 0 times. 0 times 3 is 0, and subtracting we get 2. You see, 2 is our remainder here. But we need that 0 in the position of this placeholder. Now the tendency, here's the tendency in this problem. There is a tendency to say this. You know, you learn, as you go through these and practice these, you learn that when there are no other digits to deal with, when you have dealt with all of these digits and the remainder is smaller than the divisor, then you're finished with the problem. And that seems to be the case right here. You see, we subtract it here, we get 0, we bring down the next digit, a 2. Now we're finished bringing down digits. We divide 3 into 2. It won't go. The remainder, it looks like a remainder, is smaller than the divisor, so it looks like that's the remainder in the problem, and we have 172 with a remainder of 2. That would be a mistake, because we have no placeholder here in the ones for the ones digit. We need a placeholder here. And going through and thinking 0 times 3 is 0 and making the subtraction for the remainder, that's a way to handle it. Another way to handle it is to say, well, 3 into 2 won't go. We'll put a 0 as a placeholder, and this becomes our remainder. You see, in either event, 2 is the remainder, but we have to make sure that that 0 is here as a placeholder. So the answer is 1,720 with a remainder of 2. Here's one involving a double-digit divisor. And when we have a double-digit divisor, the process is precisely the same, but we use some techniques to help us decide about the digits that are in the quotient. 34 into 1, that won't go. 34 into 15 won't go. 34 into 159. Okay, 159 is bigger than 34, so 34 goes into 159 some number of times. Now, what can help us to decide how many times that goes? That's the idea here. So we're really dividing 34 into 159 at this point. But to help us decide about the digit to put up here, we'll think about 3 into 15. See, not 3 into 1, but that won't go. So 3 into 15. Oh, 3 into 15 goes 5. So maybe 34 into 159 goes 5. You see, and this just becomes a starting point, a way to get started with the whole process. So we say 34 into 159 is something I can't imagine, but I can imagine 3 into 15 goes 5, so I'll try that as my first pass, first option. Now, 5 times 4 is 20, carry 2. 5 times 3 is 15, and 2 is 17. Oh, this number is larger than 159, so 34 won't go into 159 5 times. We'll have to make the 5 a smaller number. So we go back and we try a smaller number for the digit up here. Now, notice that the process then is one of trial and error, especially when you get into more and more digits. So we have, let's see, 4 times 4, 16, 4 times 3, 12, and 1. Now, I went through that too fast. 4 times 4 is 16. We write the 6, we carry the 1. 4 times 3, 12, and the 1 that we carried is 13. Draw the line and subtract. 9 minus 6 is 3. 5 minus 3 is 2, so 23. Now we bring down the next digit and continue the process. Now once again, we have 34 into 238 to help us decide how many times it'll go. We might think about 3 into these digits. You see, 3 into 2, no, that won't go. 3 into 23, that goes 7. So we might try 7 as the number that could be the appropriate digit for 34 into 238. All right, let's see if it is. 7 times 4 is 28. I'm carrying 2. 7 times 3 is 21, and 2 is 23. And oh, happy day, the two numbers are the same. When we subtract, we get 0, so the division goes evenly, is what we say. We can check it by multiplying 47 times 34, and we should get 1,598 is the result, and we would in this case. Here's another one, 78 into this really big number. And again, we have to go through this decision-making process. And to think about 78 into 3 won't go, 78 into 31 won't go, 78 into 314 goes so many times. And to help us decide, we might look at first digit here and the first digits here. Now, 7 goes into 31 4 times. So we might try 4 as a possibility. Now let's see. 4 times 8 is 32. I'm carrying 3. 4 times 7 is 28, and 3 is 31. Well, that's nice. Gee, this is real close. 4 minus 2 is 2. Now let me tell you another technique here that could have been used. Now this worked out really well by thinking about 7 into 31. You see, that was real nice. But sometimes it will occur that when this number is closer to the next 10, that is, 78 is a lot closer to 80 than it is to 70. So rather than using 7 as the test digit, you see, we might use 8 as the test digit. And 8 into 31 would only go 3 times with a lot left over, but we would have used 3 here, and 4 ends up working better. But I just want to tell you about that as a possible technique for some problems. Anyway, 4 was a good number to start with in this problem. 7 was a good candidate to use as the single digit, and it worked out just fine. All right, let's see. We subtracted, we get 2. Now we bring down the next digit. Oh, it's a 3. 78 into 23. 23 is not big enough. All right, remember that in that circumstance, we need a 0 as a placeholder up here, and then we bring down the next digit for division. All right, 78 into 234. Now we might think 7 into 23. That would be fine. We could think, by the way, 7 into 23, 7 times 3 is 21. So 3 might be the correct, a good start up here. The other technique, remember, is to think of this as rather than using the 7, you see in the tens digit here, we would round this off to the nearest 10, make it an 8, and say 8 into 23. Oh, 8 into 23, no, 8, that would only go 2 times for 16. But it's kind of like take your choice. In a lot of circumstances, it's better if the number is really close to the next 10, then use the digit associated with that next 10. All right, I was talking about 7 into 23. 3 times, let's see, 8 is 24, carrying 2. 3 times 7 is 21, and 2 is 23. And once again, the division goes evenly. Here again we have a 2-digit divisor, and so we're thinking 27 into 4 won't go. 27 into 47 will go some number of times, and to help us decide how many times, we might think of 2 into 4 goes 2 times, and we might try 2 on our first pass. The other way to do it would be to say, well, 27 is rather near 30. So to the nearest 10, this number is 30, and we might use the 3 in 30 as the test digit. Let's see which one works out fairly well. We said 2 into 4 goes 2, so let's try 2 here. Now, notice that I'm putting the 2 in the position for 27 into 47. I'm putting the 2 here, because that's really what I'm dividing. The 2 into 4 was just a test, you see, to help us make that decision. But it's really important to put the digits in the correct column, you see, in our quotient. At any rate, 2 times 7, 14. Write down the 4, carry the 1 in 14, and then 2 times 2, 4, and 1, 5. So we have 54. 54 is larger than 47, so our number up here is a bit too large. So it would have been a little better in this case to have used the 30, the 3 in the 30 idea for our testing purpose. So it'll go 1 time. 1 times 7 is 7, and 1 times 2, 2. When we subtract, let's see, 7 minus 7 is 0. 4 minus 2 is 2. So we have 20 at this point for our remaining digits. And now we bring down the next digit, 6. And once again, we go through that same division, that same decision process. Now, since the 3 idea worked so well before, let's try that this time. We're thinking instead of using 27, we'll use the digit that is to the nearest 10. To the nearest 10, this is 30, so we'll use 3. We'll think, well, how many times does 3 go into 20? Well, almost 7. Gee, maybe this goes 7, but we'll use 6. So let's just try 6. You see, and that's kind of a flip of the coin here at this point. 6 times 7, 42. Carry 4. We write down the 2, carry the 4. 6 times 2, 12, and 4, 16. Now I'm subtracting. 6 minus 2 is 4. 0 minus 6 won't go. I borrow from the 2. The 2 becomes a 1. The 1 that I borrow makes this a 10. So this is 10 minus 6 is 4. Uh-oh, we have a number larger than our divisor, so it would go another time. You see, it goes another time. Wow, we need to erase this then and go right back and replace the 6 with a 7. And once again, I'm emphasizing this trial and error idea. Now this is 206. I'm going to erase and rewrite that to clean it up a little bit. And, all right, here we go. 7 times 7, 49. Write down the 9, carry 4. 7 times 2, 14, and 4, 18. Draw the line. 6 minus 9, can't take 9 from 6. We need to borrow. Borrow from the 0. Oh, there's nothing there. We have to go all the way over to the 2. Borrow from the 2, it becomes a 1. The 1 that we borrow makes this 10. We borrow from the 10, it becomes a 9. And the 1 that we borrow makes that 16. So we have 16 minus 9 is 7. And then 9 minus 8 is 1. Oh, that worked out fairly well. Now we bring down the last digit, and let's divide. Now, we're again, 27 into 175, we're trying to decide how many times. Let's use a 3. 3 into 17, oh, that would be 5. Well, let's see if that works out. 5 times 7 is 35. I'm carrying 3 in the 35. 5 times 2 is 10, and 3, 13. When I subtract, let's see, 5 minus 5 is 0. 7 minus 3, though, is 4. This number 40 is much bigger than 27, so 27 will go into this 175 another time. So I need to erase here and then choose a number 1 larger than 5. And here we go. 6 times 7, 42. Carry 4. 6 times 2, 12. And 4, 16. 5 minus 2, 3. 7 minus 6, 1. The remainder is 13. So our answer is 176 with a remainder of 13 as our final answer. Here's a word problem that leads to a division for its solution. It says, an insurance agent drives a car with a 16-gallon gas tank. The agent used 128 gallons of gas in traveling 3,456 miles. Find the average number of miles traveled on each gallon of gas. And it's kind of important for us to realize what gives rise to the division. How do we know that division is involved here? Well, one strategy to deal with word problems is to identify what we're looking for. And in this problem, we want the miles traveled on each gallon of gas. Now, what that means is that we're calculating the miles per gallon. Miles per gallon. So the miles here, the 3,456 miles, and the total number of gallons used on the trip, 128 gallons, are going to be used in the calculation of miles per gallon. And I'm mentioning that here and emphasizing it because I want you to realize that the 16-gallon gas tank has nothing to do with the calculation of the problem. That is, this could be a 5-gallon gas tank or a 50-gallon gas tank, and it wouldn't make any difference in the calculation of the miles per gallon. This is just extra information that is in the problem. Some people think that you have to use every number that appears in the problem, but that certainly is not true. Okay, let's think about the miles per gallon. The per part of miles per gallon is sometimes written with a slash like this. And miles per gallon like this can be thought of as a fraction. And the fraction is this fraction, miles over gallons. Now, fractions imply division problems. The fraction bar can be thought of as divided by. That is, think of this as miles divided by gallons. And if we think of it like that, here's what gives rise now to our division. The miles is 3,456. The gallons is 128. So it's 3,456 divided by 128. And we set it up as a long division problem like this. Now, as we begin to think about it, we're thinking of 128 into the first 3 digits of the dividend. That's 128 into 345. How many times does 128 go into 345? Well, that's not easy to tell. A nice strategy here would be to think about less digits. We think of how many times does 12 go into 34? Well, let's see, 12 times 2 would be 24, 12 times 3 would be 36, and so 2 would be the logical choice here. As we think through it, we realize that it's 2. Now we multiply 2 times 128 to give 256. And now we subtract the 256 from the digits above, that is, take 256 from 345. Some borrowing needs to take place here, but we had that in the last section, and I'm confident that you can make this subtraction successfully. When we subtract, we get 89. Now, once we've subtracted, we bring down the next digit and continue the division process. And once again, we're dividing 128 into 896 here, but we think about 12 into 89. Now, this isn't as easy as thinking about 12 into 34 as we had before. We might think, well, gee, I have no idea how many times 12 will go into 89. But what I can do is think, I'm looking for a digit to multiply times 12 to give a number that's just slightly smaller than 89. Could it be, 5? Well, let's see. 12 times 5 would be 60. Well, 60 is quite a bit smaller than 89, so I might try a multiplier a little bigger than 5. I might try 6. 12 times 6 is 72. Well, 72 is still rather significantly smaller than 89, you see. And then, so I might try another number. I might try 7. 7 times 12 is 84. And so 7 is the logical choice here. Now, you can use this process, and if you go along this road like this kind of pathway of thinking, if you get to a digit that that causes the product to be larger than the 89, then you know you've gone too far. If we tried 8, for example, we'd get a number bigger than 89. So we would know then that we need to backtrack a little bit and use 7. So 7 is the choice here, and we put a 7 upstairs, and then 7 times 128 is 896. And now we draw the line and subtract. 896 from 896 would give 0. So the remainder here is 0. And our answer is 27. Well, after all of this work, do we recall what we were trying to figure out? Well, we were trying to figure out the mileage, the miles per gallon, and we want to write our answer in a complete sentence when we're dealing with word problems. So we would write, the average number of miles traveled on each gallon of gas was 27 miles.